Okay, so I am trying this face tracking. So if I look at the camera and I refresh this tab, the variables are all changing. As soon as I make my face recognizable, it can't see any variables. As soon as I bring it back, it can. You can see that on this screen right here. So I'm putting an input feed of my video and then using this face landmarks machine learning trained model, and then it's outputting this to the local host, which is 8000, which I've typed in onto the web here, and then I can just refresh it with F5 and it's all working good. So I've now using this data to import into Processing, which is right here. So I'm using the localhost data again and putting it into this JSON array, essentially, which is the way the data comes out, and then I'm putting it into this Processing sketch, which means I can start to do other things with this tracking data. So I'm running it on this display here, and then I'm exporting the tracking data into a series of just base ellipses, just as a visual, and I intend to use this to track facially, essentially. Okay, so I've now managed to get just one point of the face tracking out, which is what I wanted. So you can see the face is tracking here, and I've lowered the resolution just to make it as smooth as possible while it still can recognize that face without any issues, and I have changed it just to this one point in the array, which happens to be, I think, the nose bridge point, which is this, and then I'm taking this data, which you can see here, and I'm constraining it and mapping it between 0 and 1, which it roughly is already, but it's a little bit altered, and then I'm lerping this function, which is essentially smoothing it out so that you're getting less of a jittery sort of visual, so that it's more of a facial tracking kind of feel rather than really jittery. So if I was to remove this lerp from the ellipse, if I put the xcon, which is the constrained x, and the ycon, you would see this ellipse would become, because that's each time it tracks, which is not so nice. But as soon as you replace those with these lerps functions, which are these, it becomes quite a nice tracking sort of feel. So I've adapted the code a little bit. We've still got the face tracking going here, but I've up-res it a little bit because I was having some problems with like going a little bit too far back and not being able to recognize the face because of how reduced it was, whereas now it goes back quite far, like to around, well, I mean a very comfortable distance, but the actual frame rate isn't adapted too much, and you can go pretty close to, and it's not too distorted. So I've changed these functions here. So from the text in the ellipse, which is just a little circle moving around, there's now a stroke function, which is just creating lines on this box, which is here. Push matrix is basically a spatial conformation, so we can change the space within these lines here that are highlighted without affecting anything else in the sketch. So the push starts that and the pop ends that function. And so we're translating the origin point, which is top corner, which I'll show you. So the origin point here, it would normally be here, but it's translated to this middle of the sketch, half of the width and half of the height, which is right about there. And then the rotation x and y convert from radians, which is obviously rotate around pi, to 360, which I've multiplied it by because these lerps are between 0 and 1, and they essentially create a sort of effect where you can move your head to look around like an object, which in itself is pretty interesting for my purposes. And so for example, I could replace this size function with full screen H3D, which initiates a 3D environment within the software, and then I'll go for monitor 2, and then we'll just edit that out, and so it should come full screen here. Take the mouse away and we can move around, and it's quite a weird experience because usually within games and interactive experiences you're used to moving with a mouse and keyboard, and now it's quite odd to move your head within one of these experiences. Even in VR it's generally turning rather than like a looking around, and right now it still cuts out when my face goes off, which maybe I'd like the cube to stay, would be quite nice. But so I just moved these last couple of lines here from than this array. So basically they always run, and so this is needed if we don't have this part of the sketch. Like, it doesn't look for the JSON array over and over again. So the problem is, once it gets past this value and it's cycling round, it doesn't re-find it, and the sketch essentially runs out, which this system is causing like a little bit of lag. Like, it will cause a little bit of processing power, but it's not too bad right now. It would be nice to iron that out, but this essentially calls this less times, which makes it a little bit smoother. You can see here, like, my head's moving, and it's moving a lot smoother, and then we've just got it in full screen. So if I cut off, and you can see here the face tracking is cut out, but it's still there, and then as it picks my face back up, it reinitiates. So we get the loss, and then we get the face picked back up. The cube will stay in. So even if it cuts out visually on the tracking, the actual visual won't cut out, which means it's not so obvious. Obviously there's going to be limitations to tracking anyway, so